so lesson 2, we're going to go through the laws of logarithms. And so if you think all the way back to grade 9, and you think about how you did exponent laws, and then we think about how logarithms are just another way of expressing exponents, it makes sense that there's also some log rules. Okay, these ones are from grade 9. So if you were multiplying two different exponents with the same base and different exponents, we would add those exponents. If we were raising an exponent to another exponent, or the power to the exponent, we would multiply those two exponents. If we were dividing the same base, we would subtract the exponents, and then anything to the 0 was always 1. Okay, so those are the ones from grade 9. Okay, so from grade 9, you do have to memorize these ones. I can't spell memorize. Memorize. Okay, so those ones, hopefully they are way back in the depths of your brain somewhere, and you can remember those. Okay, these ones are on your formula sheet, so that's nice. You do not have to memorize the laws of logs. Okay, so there's a few big ones that we need to know. The first one is a product rule, just like how there was a product rule for exponents. Okay, so there's a product rule for logs. So if you have the log of a base, doesn't matter what the base is, and you have two different things, two different factors that are being multiplied, and then split that into log of the first factor with the same base and log of the second factor with the same base. Okay, so when you're multiplying, just so you guys know, this is called the argument. I talked about yesterday how it was what you're logging. I guess I should tell you the official term for it. It's called the argument. So if you have the argument of the log, and it's two different things being multiplied, we add those as two separate logs. So we can go the opposite way as well. If we have two different logs with the same base and we are adding them, we can combine it into one log and simplify that argument. Okay, so that's what we're going to do here. M and N have to be positive real numbers, and again, it's similar to the product rule of exponents. So you don't have to memorize it, it's on your formula sheet, you can always refer to it. So on this one, I have log base 6 of 4 plus log base 6 of 9. So in this case, this would be my M and my N if I wanted to refer to my formula. Okay, so this is going to be equal to log base 6 of, we're going this way, right? So it's going to be M times N, so 4 times 9. So that's log base 6 of 36. And when you've got numbers in your argument, what you're logging, you want to look at, okay, is this a number that I can really easily find in my calculator? Remember that when we're doing a log, you're thinking, what exponent does the base need to be raised to get a 36? And we know that 6 squared gives me 36, so this whole log is equal to 2. And you can always check that on your calculator. So if there's no variable in here, we want to say, okay, can we get that to a number? Okay, this one, there are variables, so we're not going to be able to just get to a number, but we want to express it as a single simplified logarithm. So instead of having two logs, we want one and as simplified as possible. Okay, so this is my M and my N. So this is going to be log, and these are common logs, right? They're base 10, and that means that we don't have to write it. We could, but we don't have to. And this is going to be x plus 1 times x minus 3. And if you want to put big brackets around that whole thing to really be clear that you're logging that whole thing, that works. And then simplified, we want to make sure that this is as simple as we can, so we're going to put it in standard form. So this is going to be log of x times x is x squared, so we're just foiling, and then minus 3x plus x, and then minus 3. So we can combine those two middle terms, so it's going to be x squared minus 2x minus 3. Okay, so that's how we would simplify that one. Our next law, and this one again is on your formula sheet, is the quotient law. Okay, so log base a of m divided by n is the same as log base a of m minus log base, a of n. So this one is really important, which one's on top, which one's on the bottom, because on the last one you could kind of interchange which was the first factor, which was the second factor. On this one it's really important that the m is the positive log, right? So see how the m is the positive log, the n is going to be the negative log, and that's always going to be true. If there's multiple factors, so if you had like log of ab over cd, this would be a positive log a and a positive log b, and then a negative log c and a negative log d, because both of these guys are on the bottom. Okay, so this should all be one line, but I can't fit it. So if log base 6 of m equals x, we're going to determine an expression in terms of x. So basically what that means is we should be able to replace some of what we get with this x. So we should have log base 6 of m, and we can switch it out with the x. So in terms of x, we want our x's in the equation instead of the m's that are in here. We want to determine an equation that's equivalent to log base 6 of 36 divided by m. Okay, so the first thing that I see here is we have a quotient. Okay, so we're going to take that log base 6 of 36 divided by m, and we're going to split it into two separate logs. So the positive one is whatever is in the numerator, and then the negative log is whatever is in the denominator. Okay, so right away, hopefully we recognize that this log base 6 of m, that's what we have. So we could replace that x right in there. This one, so it'll be something minus x. This one, we've got we've got log base 6 of 36. And again, we're asking what exponent do we need to raise this 6 to get me a 36? We know that 6 squared gives me 36. So this whole expression is going to simplify as 2 minus x. Okay, so this is a really common thing to see in terms of x. That means you want to replace whatever other variable is there with x's. Okay, and it'll usually tell you like what you can actually do that replacing with. This next example, we want to express log base 2 of 72x squared minus log base 2 of 9x as a simplified single logarithm. So we want to combine it to get into a single log. So we have something minus something else, same base. So what we can do is write that as the positive one is my numerator. I forgot the 2. 72x squared over the argument from the negative log becomes my denominator. So log base 2, 72 divided by 9 is 8. And then x squared divided by x is just x. Okay, so because we've got variables in here, we can't simplify that anymore. There's no number that can take 2, no exponent we can raise that to and give us 8x. So this just is, it's going to be variable depending on what that variable is, what x is equal to. Our last our last logarithm law is the power law. And again, this one's on our formula sheet. So if we have log base a of m to some power, so the argument, what we're logging is raised to some power, that power can come down out in front, okay? And if you're curious about how that works, I think this one's like the most abstract of them all. If you're ever curious about why that's a thing, I can show you like a proof, kind of verification of why that's true. But it's on your formula sheet, and as long as you know how to use it, you're not going to have to prove it in this class. Okay, so if you're curious, you can ask me. If not, just know how to use it. Okay, so we're going to determine an expression written in terms of k. So instead of the this whole deal, we want like simplified k's, right? We're not going to be able to get rid of k's. So since k is in here, this means that we're not going to be able to get rid of the k's. And that's okay, that we want it in terms of k. And so we're going to simplify this as much as possible. So what we need to notice here is we've got log base 3 of 81 to the 5 minus k. So I'm just going to rewrite it, log base 3, 81 to the 5 minus k. So that exponent is on our argument, what we're logging. And what this rule up here says is that when we've got an exponent, it can essentially come down in front and sit and multiply, okay? So this whole exponent, and when you've got two terms in your exponent, it's super duper important that you put that whole exponent in brackets. Otherwise, your BEDMAS would screw things up and you wouldn't actually get the right answer. So those need to go in brackets to make sure that you distribute properly. So that 5 minus k is going to come down in front, and then we're going to have log base 3 of 81. Okay, so before, when we had this, that's really hard to do, right? 3 to what power is going to give me 81 to the 5 minus k? I don't know. But 3 to the what power is going to give me 81? That's a much easier thing to then simplify, okay? So if I think through 3 to the 1 is going to give me 3, 3 squared is going to give me 9, 3 cubed, 9 times 3 is 27, 3 to the 4 is what gives me 81. And it's okay if you don't have those memorized, right? You can like punch in some small exponents, right? But the more you do this, the more you practice, the more you're going to start to see the same ones over and over again, right? You're probably getting a little bit more familiar with the base 2's, right? 2 cubed is 8, and then 2 to the 4 is 16, and so on and so forth, okay? So you're going to get somewhat familiar with some of the smaller numbers. So 3 to the 4th power is going to be 81, so that means this whole thing can be replaced with a 4. And now we can distribute that in. So we're going to have just 20 minus, oops, that should have been a 4k. Okay, so that doesn't even have a log in it anymore. It's much simpler than it was before. Okay, then we can combine them. So sometimes we need to use more than one of the rules all at once. So in this one, we've got log 100 plus 3 log 10 minus log 10,000. Okay, so what we notice about all of these ones is that they're all the same base, right? They're all the common log base 10. Okay, so we don't have to write those in because that's okay that it's not there. So the first thing that we want to do, if we want to combine logs, so notice how we've got a plus and a minus, we're going to use those quotient and product rules. But the first thing that we have to do is get this 3 up on top as an exponent, okay? Until we move that 3, we can't use those other rules. So if we look back at these guys, these logs don't have any coefficients in front of them. There's no number multiplying the log, and we can't use these rules if there is, okay? So if there is, we have to use this guy first and get rid of the number in front by making it an exponent and then simplifying. Okay, so that's the first thing that I'm going to do. So I'm going to say, okay, this is still log 100 plus log 10 cubed, right? Because that 3 is going to go up and be an exponent on the argument, minus log of 10,000. Okay, so I could punch these all into my calculator and then just add and subtract them, and that would actually give me the same result as what I'm about to do, but I think it's just going to help us practice these skills, because this is really easy to punch into our calculator because it is that base 10, it's that common log, which is a really easy button to get to. It's just right here. Okay, so right beside the 7, if I punch that in, oops, I pressed the wrong one. ln is something similar but different. You might see it in university if you're taking any math, but if you're not, you probably won't see it. And that's okay. So I could just punch that first one in, and I could figure out that log. Remember, this is base 10. What what exponent needs to go on a 10 to give me 100? Well, it's a 2. Okay, so I could do it that way, but we're gonna practice this manipulation. Okay, so when we have two logs, and I'm just gonna do this one at a time, when we have two logs that are adding together, those get multiplied. So those arguments get multiplied. So I'm gonna write this as log of 100 times, and I'm gonna write 10 cubed as it's multiplied out. So 10 times 10 is 100 times 10 is another 1,000. Basically, the exponent on a 10 just tells you how many zeros there are. And then that's minus log of 10,000. So then we've got log of, so this whole thing is 100,000, right? So 1,000 times 2 more zeros is 100,000. And so we've got 100,000 minus log of 10,000. So when we've got a log minus another log and they're the same base and there's no coefficients in front of them, we can take that first log, that positive log, and I'm going to multiply that out in there and then divide it by the second one. So what we get here is 100,000 divided by 10,000, that's just 10. So now we just need to remember that, hey, this is base 10, so remember this is base 10. So we're thinking 10 to what exponent needs to give me a 10, or what do I need to raise 10 to give me 10? It's a 1. Okay, so this just is a 1. This next one, so we've got express 3 log base 8 of y minus 3 log base 8 of y to the 4 plus log base 8 of x, okay? And so we're going to simplify this out. Okay, so again, I'm going to just kind of do it working across. Okay, so we've got, oh, the first thing that I need to do, never mind, I'm going to do this first. I'm going to move that 3 up. So that's my first line. So it's going to be log base 8 of y cubed minus log base 8 of y to the 4, and you can put those in brackets if you want, plus log base 8 of x. Okay, so this first one, we're going to do log base 8, and the one that's a positive log becomes my numerator, and the one that's a negative log becomes my denominator. Okay, oops, that's a plus. So either we can simplify that or we can multiply it right away. Okay, I'm going to multiply it. So now we've got 2 logs and we've got the same base. Oops, I forgot the base. We've got the same base and we've got one argument and another argument. We're going to multiply these guys. So log base 8 of, this is the same as x over 1. So it's going to be y cubed times x, and then y to the 4 times 1. So I'm just going to write y to the 4. Okay, then we want to reduce this thing. So this is log base 8, and y cubed divided by y to the 4. The cubes cancel out, and there's only one y left on the bottom. So this is going to be just x over y. So we've got a single simplified logarithm. The last one that we need to know and be able to work with is what we call a change of base formula. So sometimes you could use a change of base. And this is really in particular situations where the base that it gives you isn't the most ideal base, or maybe you're like me and you don't have the ability for your calculator to enter a base. So as I was saying, last time I didn't have my calculator with me, so I couldn't even show you guys this, but I showed you just a few seconds ago where the log base 10 button is, right? So if there's no base, there's a 10. In most calculators, and like the newer ones, you can hit math and you can scroll basically all the way down and you should be able to get to one, I think it's like option A or B or something, that says log base. And it's gonna come up with like, so it's just hit math and then scroll down a bunch to log base. and it's going to come up looking like this. And then you just use your like left and right arrows to scroll into those boxes and give it the appropriate thing. Because my calculator doesn't have that, I've gotten really good at what we call the change of base formula. Okay, so I need to change everything into a base 10 log in order to be able to evaluate. So we're going to do that for the first example here. Okay, so the change of base formula, again, this is on your formula sheet. Basically, it says if you have log base b of c, and let's say b is not base 10. So on my calculator, I can't do it. Or maybe there's other situations that you need to change your bases for. You can change that to any base that you want. So introduce a different number, so a, and then what the rules are is the argument is the argument of the top log, and the base of the original log is the argument of the bottom log. Okay, so kind of one of the ways that I like to think of it is the bigger number goes on top, the smaller number goes on the bottom. Kind of like, think of like a food chain. Bigger goes on top, right? And we can make that base whatever we want. So we're going to do that here. So if we want to solve this expression to the nearest tenth, this means that we need to use our calculators. Okay, so again, you guys, most of you will have the newer calculators and you can do this with the basics, but I want to show you in case you ever have to use the change of base formula, and the diploma could make you do it. It could say like, hey, write this log with the change of base form and then put them into numeric response boxes. What did you make A, B, and C or something like that? And that would be a way to test, hey, can you do this even though you haven't had to on your calculator? So you do need to have this as a skill. Okay, so if I want to change this base, the first thing that I need is to get one single log. So I'm still going to have to use my log rules. So this is going to be the product rule. So this is going to be log base 6 of 4 times 13, which is 52. Okay, so we're going to do this as log base 10. Okay, so I'm going to write this as log base 10 over log base 10. The big number, the argument, becomes the big number, the one on top, the argument of the top log, and then the base becomes the argument of the denominator log. Okay, so I chose base 10 because it's the easiest to punch into the calculator. But we could have used any base. We could have made those 2s or 4s or 6s or whatever, as long as they are the same. Notice how it's A and A. It's not like A and Q or P or something different. They have to be the same. Okay, so then what I'm going to do is I'm just going to punch this in. So log base 10, remember, is my default. So 52 divided by log of 6. And so I get 2.20. So 2.2 is my nearest tenth. Okay, and again, if you went from this point, you could check using the instructions up there for the change of base. Okay, so this last one, I realized after I printed it, this question doesn't actually work. So we're going to start it, and we're going to talk about where we get that actually makes it not work. Okay, so what the question asks us to do is express this whole thing. So we've got 3 log base 2 of x plus 9 log base 8 of 5x as a single simplified logarithm in the form of log base 2 of a. Okay, so we want it all as one big log base 2. Okay, so that right away thinks, okay, change of base formula, we can do this. But I'm going to show you where we run into an issue that I didn't actually think about. So this one, again, anytime we want to manipulate logs, combine them, we want to get those coefficients up as exponents. So this is going to be log base 2 of x cubed, and then plus log base 8 of 5x to the 9th exponent. Okay, so because we're trying to get to log base 2 of something, I'm going to change this base to log base 2's. Okay, so I'm going to leave this whole thing and I'm going to make this log base 2 over log base 2. The argument, the thing I'm logging, is my exponent in the top one, so that's going to be 5x to the 9. And then my base on this top one is going to be my argument on the bottom one. Okay. So now we've got a log plus a log divided by a log, and it thinks, okay, we can combo this. Okay. When we've got a log plus a log, we can combo the arguments. We can multiply them together. However, there's nothing that we can do to combine this. Okay, so in none of our rules is there a part where we say log base 2 of something. Like this could go back to this guy, right? We could change this back into that, but that's the only thing that we can do with a log divided by another log. When we can have things divided, it's log base 2 of something divided by something else, and we can split it, right? It's log base 2 of m minus log base 2 of n. Okay, but that's not what this is, right? We've got two different logs, so we actually can't combine anything. Okay, so we can't actually go any further than this. So that was an oversight on my part. I just found a question and was like, yeah, this should work, and didn't actually work it through until after I had printed it for you guys. So, but it's a good thing to see what you can't do. Okay, so that's the lesson for today. If anything didn't make sense, be sure to let me know, ask questions about it. There are pages in your snap book that talk about it more and more examples and that kind of stuff. And then you guys should be doing the practice from this section of the snap book. Okay.